Hello everyone. So previously we had successfully designed a configuration manager system. Yep. So today we are asked to design a TikTok, this one, game actually. Yeah. So this is going to be the last problem that we are solving in this playlist. This is going to be the last problem that we'll be solving in this particular playlist, right? So after this, I'll be taking a break for at least a month or two, right? So at least 1 month or 2 months, right? So I'll not be doing anything. I have to prepare for something. I'll not be doing anything again. So this is going to be the last game in this particular playlist. We will be successfully solving 50 problems, right? Yeah, 49 problems we have already solved. This one LLD based problems. So now this is going to be the last problem as I've said. So let's see what the question states here. Design a console based tic-tac-toe game for the two players. The system should validate moves. Yeah, this is one of the things that we have to keep in mind. The system should validate move, update a 3 into 3 board. So we'll directly connect 3 into 3 board. Yeah. So update a 3 into 3 board, detect wins or draws. That also the system has to do. And display the game state after every turn. After every turn, we have to display the game state. Yep. So implement the full game loop in a single Python file without external dependencies. So we don't have to worry about the external database. We have been asked to go with the in memory. We have to consider the in memory. That's what they have asked here, right? So very simple one, right? So based on the question, let's do one thing. Let's collect the functional as well as the non-functional requirement in detail so that we can move on with the further things. First, let's collect the functional as well as the non-functional requirements in detail. So here, the first functional requirement would be the system must allow two players to play alternately on 3 into 3 grid. Yeah, the system must allow two players to play alternately on a 3 into 3 grid. So we don't have to worry about the concurrency here. First, the first player has to play, and the second player, then the second player has to play, right? So we don't have to worry about the concurrency here, right? So just for the demonstration purpose, right? I'm speaking of. The system must detect win conditions, whether it may be row, column, as well as diagonal or the diagonal. The third one, the system must detect row conditions when the board is full. So this is one of them. The fourth one, the system must not allow invalid moves. The fourth one, the fifth one, the system must print the game result as well. So this is one of the things. Yeah. So these are some of the functional requirements that we have to keep in mind. The system must allow two players to play alternatively on a 3 into 3 grid. This is fine. The system must detect win conditions, row, column, as well as the diagonal, based on the row, columns, as well as the diagonal. The system must detect draw conditions as well when the board is full. This is also one of the thing, one of the requirement actually, which is very important. The system must not allow invalid moves. So this is one of the um, requirement. This is also very important. The system must print the game result. Yep. So this is fine, I believe. Next, let's move on with non-functional requirements. The code has to be simple, clean, single file runnable Python script. Yeah. So this is fine. No external databases. All the data held in memory. All the data held in memory. So we don't have to worry about the external database. So we just have to uh, consider in memory. Yep. So the third one, code must be easily extensible. Extensibility, we have to keep in mind this one, right? Every time we write the code, we have to keep in mind about the extensibility. Yep. Code must be easily extensible to n into n boards. This is the third one. The system must not allow invalid moves. The fourth one. The final one is the system must print the game result. Yeah. So this is the final one. This is fine, I believe. Next, let's move on with the algorithm choice and the design pattern choice. Yeah, the system, I mean algorithm choice as well as the design pattern choice. The first thing here, algorithm choice. So we will be considering board as to-do list, right? That is updated after every move, right? So we'll be considering board as to-do list. This is very important. We'll be considering as board as to-do list updated after every move. So we will be going with a constant time um, win checking after each move by inspecting the moves row, columns, as well as the two diagonals, right? So this one, moves row, columns, as well as the two diagonals. Just keep this in mind. This is very important. Yeah. So it will be, the algorithm will be simple turn-based loop until the game ends. Yeah. So this is fine. This is easy to understand. Yeah. So this is the algorithm choice that we'll be making use of, and it's simple to understand as well. We are not going with any complex algorithms, or we are not implementing any complex algorithms here, and we are just going with in memory as well. We are not considering any external database, so this is going to be somewhat easier, right? So implement basically. Now let's move on with the design pattern choice. Mainly we will be going with a model controller pattern, right? So lightweight MVC, right? Model view controller, model controller pattern. So model, it consists of the board plus game rules, and the controller, it orchestrates, turns, validates the moves, and checks the game state. Just remember this one, we'll be going with a model controller pattern. Yeah. So this is important. Yeah. So model consists of the board and the game rules, board along with the game rules. Controller, what it does, it orchestrates the turns, validates moves, and checks the game stats. This is what the controller does. Yep. So let's move on with the further things. Now, as we have completely discussed the algorithm choice as well as the design pattern choice, let's move on with the concurrency as well as the data model discussions. Yep. So concurrency part, no concurrency is required here. Two players take strict turns. Yeah. No concurrency is required. As I've said, by the question itself will understand this one, right? No concurrency is required because two players take strict turns, meaning first player will first when it is first player's turn, he has to play. Then after finishing the this one, after first player finishing his turn, then only the second player has to start, right? So then here no concurrency is required, right? Two players take strict turns. The second one is turn execution is atomic. Yeah, this one is important. Turn execution is atomic. Only one writes at a time. Only one writes at a time. So concurrency is not required here. If extended online, then we can add server-side lock of atomic server-side lock or atomic operations, right? So we have to write the code based on the extensibility, keeping the mind, keeping the extensibility topic in the mind. Always we have to write the code. Just remember this one. Yeah. So concurrency is fine. Next, let's move on with the data model part here. Board, so this one we'll be going with a board list of this one string, actually storing this one, the first player turn X. So this one will be going with a 0 or O, right? So this is fine. Initially empty string. Yep. So this is fine. List of string. So players, simple strings. So first player and the second player will be making use of this one. X and O. Right. So this is fine. Yep. So the game state. So we will be going with the current players board as well as the status. Status. For the status, we'll be going with the three status. Actually, one is running and another one is win, and the third one will be draw. Either it will be running. The game should be running. Uh, and after this one game has ended, we have to show either it's a win or a draw. Yep. So this is fine. So this is about the data model, right? So just pause the video and have a look into it, right? So we are not going with any external database. This is simple, right? So this is the simple one, as we are not going with a this one external database. You should have the uh, this one, what do we call, understanding of the database actually completely. Whatever the database, uh, this one you are implementing or you will be implementing, if you are going with the data modeling, there will be database administrators for that, right? So usually for the data modeling part, so that will be done by the database administrators, and the this one usually backend developers and the database team, database administrators, or this one related to the database, this one team, actually they'll uh, this one team up, and then they'll be doing this one, right? Usually database administrators or the architects do this job actually. uh, the data model I'm speaking of, actually data modeling is done by the database architects or the database this one administrators, right? Usually, right? So they will be designing this part and they will team up with the backend developers, so that based on that itself they'll be writing the code, or they'll be going with the implementation part usually, right? So this data model part, again, I'm going to tell. So just pause the video and have a look into it. We are not making use of any external database. As we are going with the in-memory, implementing this will be quite easier, right? Not completely easier. You should have knowledge on the programming language, no doubt. But as we are not going with any external database, we don't have to have the this one complete knowledge on the database part. That's what I meant actually. But in real world, this one, if you're solving the real world problem, then you have to have the knowledge of database that you are implementing, whether it may be NoSQL or the SQL. So you have to this one have the knowledge on the database at any cost. If you are a backend developer, you have to have the knowledge on database. That's necessary actually. Yep. uh, this is fine. Yep. So just pause the video and have a look into it. So we are done with the concurrency model and the data modeling part as well. Yep. So we are done with the concurrency as well as the data modeling part as well, right? So again, usually UML diagram will be designed by the software architects, right? Usually, and data modeling will be done by the database administrators or the this one database architects, right? So this is one of the thing. And whatever the code that we write after the diagram, this one after discussing the UML diagram. So usually UML diagram, if you are going with if you are solving the real world problems, it will be the software architects will design the UML diagram, and this one they'll go with a or they'll design. Um, this one they'll go with high level this one, right? UML diagram, not the textual representation. So we for every problem I have went with the textual representation because it's easier to understand here, right? So what are the things that will be implementing the exact same thing will be implementing in the form of code, right? That will be done by usually software architect. So this data modeling part and the whatever that is related to the database, that will be done by the database team, right? So database team, right? So usually it will be done by the database administrators or the database architects, right? So they'll team up and then they'll be writing the code, the backend code, the backend side, right? So next, let's move on with the this one UML diagram. After discussing the UML diagram, we'll be writing the code, right? So we will be adding the logic to the this one methods or the this one functions that we'll be making use of within the code, right? So that thing will be done by the developers actually, whether it may be if it is on the front end side, that will be done by the front end developer, and it will be if you are implementing something on the back end, that those things will be done by the back end developers, right? Usually currently after this one AI has come into existence, people are hiring mostly based on the this one your full stack itself, full stack experience itself, right? AI is evolving, uh, right? AI is evolving. So usually people are hiring for the this one full stack developers. So mainly this one, what do we call? The how do I put it actually? Yeah, mainly the logic part will be written by the this one developers actually, SD, right? SD people, whether it may be front end or the back end, right? So again, this one data modeling will be taken care of the database administrators or the database architecture, usually database team. So this one, software architects will this one, what do we call? Will take care of the high level this one UML diagram. So they'll design what are the things that we have to use, right? What are the parameters that we need to use? What are the this one methods that we need methods that we need to use? Whether we have to go with a class, whether we have to go with this one. Only functions are necessary. These kind of things will be taken care of this one. What do we call? Software architects actually. So then the logic as well as the other part will be taken care of this one developers actually, right? So then it goes through the testing and other phases, but these three things, right? So this is fine. Yep. So now within the UML diagram, based on what we had discussed earlier, within the algorithm choice and the this one design pattern choice and also the concurrency and the data model part, I have designed an UML diagram actually. So this is the textual representation as I've stressed this one earlier. So this is not the high level, complete high level this one UML diagram. We are just going with a textual representation. It's easier to explain and it will not take much time. So that's the reason we go in this way. I chose to go in this way, right? So this is just the again, this is just the textual representation. So we will be going with a tic-tac-toe class actually. So this is going to be the base class or the main class. So we will be going with only one class, nothing but tic-tac-toe class, right? So it consists of two parameters. Yeah, it consists of two parameters, namely board as well as the current player board, which consists of the 2D list, and current player, which is of the type string, right? So, and within the tic-tac-toe class, actually, we have five methods. Yeah, we have five methods, namely make move of this one. R commas is nothing but the row and column. Switch player, we should be able to switch player, so we'll be going with the switch player method. Check when, we have to check whether win, draw, or this one win or draw. Yep. So first running win or draw we have to check actually. So we will be writing methods check and draw actually, check win and check draw method, and finally we should be able to display the board again. So for that we'll be going with the display board method. So these are the 5 methods, and we are going with a 3 into 3 board directly, right? So we are not yeah, we are going with the 3 into 3 board directly, right? So this one also we have to keep in mind. So this is about the UML diagram. The exact same class, the exact same parameters and methods we'll be making use of within the code that we'll be writing in the future. The only thing is we will be adding this one, what do we call, we'll be adding this one, the logic to the methods, and we will be writing the code structurally. That's the only difference, right? So based on what we discussed earlier within the algo choice and the design pattern choice and the concurrency and the data model part, so this is going to be the UML diagram, right? So yep. Again, it consists of the tic-tac-toe, which is the base class, tic-tac-toe class, which is the base class, and it consists of two parameters within the tic-tac-toe class, right? So board as well as the current player board, which is of this one 2D list, which will be initialized with a 2D list, and current player, which is of the type string. And we'll be going with 5 methods within the tic-tac-toe class, nothing but make, move, switch player, check one, check, draw, as well as the display board. So this is about the UML diagram, right? So now we have discussed the most important points. Based on that, we have designed the UML diagram as well, right? So we have discussed everything within the UML diagram. Now we have the complete idea on how to write the code, right? It's very good time to write the code. Let's start writing the code. So let me do one thing. I'll just go with this one. What do we call? Class. First, let's go with the class structure. We have done important. Sorry, no, right? So let's go with the class tic-tac-toe. So this is going to be the base class actually, or the this one. What do we call? Main class actually. Yep. So I'll just go with tic-tac-toe here, right? So this is fine. So within the tic-tac-toe, the first thing I'll be going with here is initialization part. Let's move on with the initialization part. This has to show. Yep. Along with the self, I don't need anything, I believe. First, let's go with the initialization part. Let me initialize the board with. So this one, just go with the empty string here. Let me leave the space. Let me go with the for loop here. So in the range, what's the range actually? We are going with a 3 into 3 board, n into n board, right? So we are considering 3 into 3 board, where n is 3, right? So this is fine. Mm, Again, let me go with for row is 3 and column also. Let me set this one to the 3 in the range 3. Yep, so this is fine. We have successfully created 3 into 3 board. Uh, this one. Okay, so this is fine. Next, what we will be doing, let's go with initially x and o are the characters that we are considering, right? X will be used by the player 1 and o will be used by the player 2. So x always starts the game. We know this one, the player 1 always starts the game. So let me initialize this one with current player with x actually. Yep. So I'll just go with the x. Next, let's do one thing. Let's go with the display board method. Yeah, I'll just go with display board method. I'll just pass the self here. So within the display board method, first we have to iterate each row. So I'll just go with for row, and let me go with board. So this is also fine. Within the for loop, we have to print the row with separators, right? So I'll just go with print here. So this is fine. Yep. So I'll just give here join of, let me pass the row. Yep, so this is fine. Next thing what we'll be doing, I'll just go with a print. So let me pass the print here. I'll just give some dots, right? So this is fine. Yep. Next, after the display board, let's go with a make move method. Yeah, I'll just go with def make. Yep. So within the make move, so I need two parameters. One is row and column. As per the UML diagram, I'll just go with R and C respectively. So first we have to check the boundary validation, right? So let's go with the boundary validation. If R less than 0, it shouldn't be row less shouldn't be less than 0, and row shouldn't be greater than 0 as well, right? And equivalent to 3, or column less than 0, or So this one, column greater than or equal to 3, then what we have to do in that case, we have to return false. Yeah, we have to return false in that case. And let's give some message. I'll just give here invalid. Let me give here invalid position, right? So let me give here invalid position. So this is fine. Yep. This is the boundary validation. This is fine. Next, let's do one thing. If the cell must be when the cell is empty, right? So I'll just go with board actually of R and C not equal to empty string. Then what I'll do? So I'll just return false here. I'll just return false here. I'll just give cell already taken. Yeah, so this is fine. Next, what shall I do? So let me place X or O on the board. So I can just write it in this way. Board of R C. Let me assign this one to the uh, current player actually. This one. Yeah, let me return true in that case. I'll just go with return true. So let me give some message within the strings actually. I'll just give move accepted actually. Yeah, move accepted. So this is fine. So we are done with the make move method actually. Next, let's do one thing. Let's move on with the third method, namely switch player. Right, I'll just go with switch player here. Switch player of so we don't need anything because we are just switching the player right here. All we have to do is toggle X and O here, right? The player turns actually. We have to toggle them, right? So I'll just go with current player. So let me assign this one to the O. This is fine. Go with double inverted comma instead of the single inverted comma. So this is fine. Yeah. If current player X, so this is fine. Else, let me go with fine. We're just toggling between X and O, right? So we are done with this method as well, switch player method. Next, let's do one thing. Let's go with a check when method. So I'll just go with check when. So this is fine. Let me pass the self here. This is fine as well. So within the check when method, we have to go for the alias for board as well as we have to go for the alias for player, right? For the board, I'll just go with this is fine. And we will be going with the this one, current player, right? So this one. So this is fine. We have to check each row. We have to check each row in the sense, if all the cells match the player symbol, then in that case, we have to return true. For that, we have to write the for loop, right? So I'll just write it in this way for row in V, right? So let me give the colon here. So as discussed, I'll just go with if all cell, if it is equivalent to the value P, then for cell, now the error has to be gone. For cell in a row, so this is fine. We have to return true in that case. Yeah. So this is it for the for loop actually. Next, also we have to check each column as well. If vertical, then we have to consider three match, right? So I'll just go with for C individual column in range of three actually. So within the for loop, first let me go with simple if all of B are C, if it is equivalent to the P or R in range of 3, so this is fine, then we have to return true in that case. Yep, so this is fine as well. Yeah, we are done with the for loop. We are checking for the each column here, right? So next what we will be doing, we will check the primary diagonal. We have to check the primary as well as the secondary diagonal both, right? So first let's check the primary diagonal. So I'll just go with if all of B of I, So if it is equivalent to P for I in range, we are considering 3 into 3, right? N equals 3 basically. So let's go with the 3 here. In that case, we have to return true. Yep. If everything goes right, in that case, we have to return true. And also we have to check the secondary diagonal as well. So let me copy the same thing over here, this one, and let me paste it over here. If all of b of I, so this one will be 2 minus I. Yep, so this one will be 2 minus I. So if this is equivalent to the p for I in range of 3, so then also we have to return true in that case. Yeah, so this is fine. Next, else we have to return false, meaning if no when found, if it is draw, then we have to return false in that case. Yeah, so I'll just go with a false. Simple. Now let's do one thing. We are left with only one method. I believe we have to go with a check draw method as well. We have to check the draw, right? So if no one can win, right, after the game has ended, if no one can win, in that case, we have to declare draw, right? So for that, we'll be writing check draw method actually. I'll just go with def check draw. Check draw. Let me pass the self here. So within the check draw method, first thing, let me go with a for loop here for or in range of 3 for column in a range of 3 again. So this is fine. If board, this one, if board of we have to consider row and column RNC. If it is equivalent to the empty, meaning if any empty cell exists, right, then it's not a draw. If any empty cell exists, then it is not a draw, right? Quite obviously. So if you know the rules, empty cell shouldn't exist. Player has to play, right? After the game has ended, if both the players has not won, in that case we have to declare a draw. If still there exists the empty cell, then we have to return false in that case. It's not a draw yet. We still have the uh, game actually. We should still go on with the game or move on with the game actually if there exists an empty cell. Yep. So let me do one thing. In that case, let me return false actually. Yeah, in that case, let me return false. Else let me return true actually. So what will I do? I'll just come here for the first loop. So here, so I'll just give here return true. Yep. So this one. Yeah. So board full. Yeah, this is fine, man. Let's do one thing. Now we are done with the coding part. Yeah, it's simple. Now we are done with the coding part. It's simple. Let's do one thing. Let's move on with the final part. Nothing but so usually uh, we will be going with the example usage or the demo usage, right? So we'll be considering example usage or the demo usage from the Google. Let me do that. Just give me a second here. So I'll do one thing. Let me paste this one over here. So this is fine. So I'm just calling the tic-tac-toe game over here, right? So this game. So this is creating the game instance, right? So this is creating the game instance. Yep. So this is fine. Next, what we are doing, we are going with a predefined move sequence showing this one X winning diagonally, right? So moves 0, 0, 0, 1, 1, 1, 0, 2, as well as the 2, 2. So we have considered this one. Again, we are going with a predefined move sequence showing X winning diagonally actually. We are just going with this part, right? So let me do one thing before explaining. I'll just run the code and let me run the code and let me explain this one. I'll just go with, let me give clear screen here. Yeah, just type Python followed by the file name dot py. Yeah, so see here. First thing what we are doing, we are going with the predefined move sequence showing X winning diagonally, right? First X move, first X is at the this one, first 0, 0, right? If we are going with the 3, 3 board, right? So see here, let me show you this one, or let me enlarge this one actually. Yeah, we are going with this, right? First move. So what we are doing again, we have went with a predefined move sequence showing X winning diagonally. So this is fine. We have went with a for loop. We are showing whose turn and position actually. Yep. So first move is X and X has placed here, right? Player one has placed the X here. So this is fine. Player O moves 0, 1. player almost 0, 1. So this is the player first. This is the player this one, player 0, right? Player 0 has place the X over here. Player 1 is moving. Again, we are going with a predefined move sequence, right? Showing X winning diagonally. We have considered this one already. X will win. We know this one. So 0, 1 in the sense, so the next one. So the next grid. He is next cell actually. This one, the player 2, sorry, not he or she. The player 2 is placing the O actually in 0, 1. Yep, so this one. Yep, so this is fine, I believe. Next, player 1 is placing the X at the cell 1, 1. So this one 1, 1. Yep, so this is fine. Next, 0, 2. Player, this one almost 0, 2. So move is accepted. Everything is this one running smooth because every condition is met. Yeah. So this one player 2 has placed the O here, right? Player 2 has placed the O here. Next, player the 1 has this one place the X at the cell number 2, 2 here, right? So 2, 2. See here, in this case, this one player 1 has 1. Player 1 has 1 actually, right? Or player 1, yeah, player X wins or player 1 wins actually. Player 1 is nothing but the X, player 2 is nothing but the O. Player 1 wins here. In our case, uh, we are calling the player 1 as X and we are calling the player 2 as O actually, right? So you can change this one and check. We are just going with a predefined move sequence showing X winning directly, right? So you can just make the O win as well. So we are just going with a predefined move sequence. That one you have to remember. That's it. Yeah. So see here, and again for R, comma C in the moves, we are just showing whose turn and position. So this one, player X turn and position as well. So 1, 1. This one we are doing with the help of this one for loop actually. Next, we are attempting the move, we are printing the move result, we are showing the updated board. These three things we are doing. Then what we are doing, we are checking the winning condition as well. Finally, we are going with a meaning we are checking the draw condition as well, right? So win, draw, or yeah, win and draw condition that we have to check. Initially running, so if the cell is empty, then until the cell is empty, you cannot. If the player has won already, then we have to show that player has won, right? So we cannot go with a draw until all the this one, what do we call? All the cells are filled with either X or O, right? So that is the condition that we have written, if you remember. Yep. So this is fine, I believe. Finally, accordingly with the rules of the game, X, see here, diagonally this one, left to right. This one diagonally the X has 1 here. So we are displaying player X wins here in this case. Yeah. So whatever the code that we have written works absolutely correct, right? So we are getting the desired output accordingly with the demo or yeah, demo usage or the example usage that we went with, right? So this is fine. Yep. Next. Yep. We have discussed the coding part, right? So we have discussed the output part as well, and we have got the desired output as well. We have got the desired output as well. As we are done with um, these three things actually, it's time to move on with the further things. Let's discuss the limitations for the code that we have written. So the first limitation here would be it only supports a 3 into 3 board. Yeah, it only supports 3 into 3 board. It is not scalable for the custom board sizes. Yeah, it's not scalable for the custom board sizes. So this is one of the limitation. The third one, no graphical UI. We are not going with any graphical user interface or the UI. So it's purely console based. Yeah. So this is one of the limitation. The third one, no AI player, right? It's complete minimax. We are going with a minimax. So this is fine. The fourth one would be no multi-user network player, right? So not network player actually, it's network play actually. Sorry. No multi-user network play, right? So this is one of the limitations as well. The fifth one, no input-based interaction. No input-based interaction in the sense it uses only pre-coded demo modes, right? So that we are just going with a or we went with a predefined moves just to show the output in the console, right? So if you remember, so we are not going with any input based interaction. We are just making use of predefined demo moves. Yeah, this is one of the thing. Finally, let's move on with the main thing, nothing but alternative algorithms and the trade-off. So we are done with the limitations part. Next, let's move on with the alternative algorithms and the trade-off, right? The first part here would be minimax AI algorithm. When I say minimax AI algorithm, the main advantage of using it is unbeatable AI. So we can just go with the unbeatable AI. And also the main con or a disadvantage would be exponential for the larger bots. Yeah, exponential for the larger boats, and it needs pruning, right? Pruning in the sense we have to go with the alpha beta, right? So that's nothing but the pruning. The second one is we will be going with a, or we can just go with the n into n board generalization as well. So this is one of the algorithms that we have that we can consider. So first we can just go with the minimax AI algorithm. So this we have discussed. Next, we can go with the n into n board generalization. Nothing but mainly the pro of using n into n board generalization is nothing but it will be flexible and dynamic, no doubt. But the trade-off would be it requires scalable win check logic. It requires again scalable win check logic. Let's move on with the third one here. We can just go with the event driven design as well. So the main advantage of using the event driven design algo or the approach is that it is completely good for the GUI, graphical user interface, or web, no doubt. But the biggest con here would be it is complex for simple console game. It will be completely complex for simple console game. Let's move on with the fourth one or the final one, client server multiplayer. The main advantage of making use of client server multiplayer, this thing, what do we call, approach would be this one, real online play, right? So the main advantage is that we can just go with a real online play. The biggest con or the trade-off that it would come with is it requires this one, networking as well as the concurrency control. So these are some of the alternative algorithms that we can consider. Yeah, so these are some of the alternative algorithms that we can consider. Yep, so this is fine, I believe. Yeah, these are some of the alternative algorithms that we can consider. This is fine. We have successfully designed this one, tic-tac-toe game, right? So now, yep, I hope whatever we have discussed is completely clear, man. Yep, so I hope whatever we have discussed is completely clear. This one, what do we call? Yeah, I hope whatever we have discussed is completely clear, along with the UML diagram as well as the coding part. Yep. So this is, as I've said, this is going to be the last problem that we'll be solving in this particular playlist. So we have successfully solved 50 problems, right? So this is more than enough in my opinion. So this is more than enough. We have solved 15 problems using the JavaScript programming language, LLD problems. We have solved 10 problems in Java. The main 10 problems in the Java, same LLD problems, and we have successfully solved 50 problems in Python, which is more than enough. Yeah, which is more than enough. Yep. So this is just for the practice actually. If you're going for the system design round, so again, what are the things that we need to know here? Let me tell you one thing. What are the things that we not need to know here? First thing, you have to know the basic definitions and basic things, right? So whether it may be sharding, whether it may be this one, scaling, vertical scaling, horizontal scaling, load balancers. What is system design? First of all, why we'll be making use of this one? Why we will be going with the system design, right? So these things, yeah, you have to know at any cost. Then comes the main things. You have to know certain principles. We have to know the solid principles. We have to know DRY. We have to know YAGNI, as well as we have to know KISS principles, right? So these are the basic things you have to know. And solid principles you have to know at any cost. Yeah, solid principles you have to know the solid principles at any cost. Apart from the solid principles, you have to know DRY, YAGNI, and KISS. Yeah, so this is fine. Next comes the this one, OOPS concepts. You have to know the OOPS concepts, man. In the system design interviews, most of the times you will be making use of the this one, class itself rather than the functions, right? So this one, you have to know the class objects, the topics like inheritance, this one, abstraction, uh, then polymorphism. Those topics you have to know. Most of the important, this one, what do we call, OOPS concept. If you don't know solid principles, those are this one, the videos are present in the this one, what do we call, solid principles, and the DRY, YGNI, this one, and KISS principles we have discussed. That is present in that playlist itself. Actually, you can check. That is one thing. Then if you don't know the OOPS principle, we have discussed the OOPS principles as well. That is kept, I mean, the videos are inside the OOPS principles, sorry, OOPS concepts playlist. You can check that as well. Then after that, you have to know different design patterns. There are some this one 15 to 20 patterns that we need to know. Among them, the 10 patterns. Basically, we'll be making use of the 5 or 6 patterns that we need to know at any cost, right? Usually some 6 to 7 patterns we need to know at any cost actually. Yep. So we should know that one. We have discussed that one as well. It is present in the design patterns playlist. You can check that one. We have discussed around 10 different design patterns. We have discussed using the JavaScript programming language as well while solving the JavaScript problems. We have discussed using Java as well while solving the Java, and we have discussed this one different design patterns using Python programming language as well. Whichever you are comfortable with, you can just watch the video and then you can move forward with the other things. Right? After knowing these things, uh, try to solve the problems. Yeah. So you have to know the basic definitions and basic things about the system design. And then comes the part. So you have to know this thing. What do we call? OOPS principles, solid principles, DRI, YGNI, KISS. Then comes the OOPS concepts as well. You have to know. Then different design patterns. These things you have to know for the system design and before solving the LLD problems. And also you have to be good with this one as well. What do we call? Uh, High level design as well, right? So while you're going with a high level design, while you're solving the LLD problems, you have to go with a high level diagram itself, the UML diagram, right? So you have to know certain things. How does the high level design work for certain problems? Mostly some of the companies only go with the HLD. They'll not be asking the LLD problems. Yeah. So they're not focusing on entirely on the code. Actually, they'll be focusing on the theoretical part and your this thing. What do we call? How much you know about the this thing, certain key CS concepts actually. Yep. So that also they'll be concentrating on rather than going with the LLD. Every round will be based on this one coding itself. So one round they will be going with the HLD as well. Some of the companies, yep, rather than the LLD. Yep. So you have to have the knowledge on HLD part as well, right? So and yeah, these are the things. And also you have to have the knowledge on a database, any database. So here we are just solving the problem. So we have went with in memory for all the 50 problems. Actually, we have to discuss about the databases while writing the code. We have to keep in mind about the term extensibility, right? It should be extendable at any cost. Whenever we are writing the code, we have to uh, right, we have to think of the extensibility and whether the code is extendable for the future, this one for the in the future or not. Keeping this in mind itself, we have to write the code. Yeah, this one also we have to keep in mind. This is also one of the things. Yeah. uh, and these things we have to keep in mind. And yeah, we have to have the knowledge on database as well. Yep. So because the data modeling and the other part, at least theoretical knowledge and some good knowledge, right? At least you should have done some this thing, what do you call, basic knowledge, I mean. Some projects that includes the databases, right? So any backend project that includes the database, or any full stack project that you can go with, right? So some at least 2 to 3 or 4 to 5 projects you should have done, right? So you should have knowledge on the databases as well, databases. And if you should have knowledge on any language, that doesn't matter, any language that you are very comfortable with. This one, especially I prefer Java, JavaScript, or the Python. The first preference Java, this one. The second one JavaScript, or this one also the Python. Yep. So these three, any language you can go with, right? So apart from this, you can just go with any other language as well, if you're comfortable with. So it's better to go with these three languages. Any one particular language you have to be good with. Yep. You should be able to write the code, right? So you have, after designing the UML diagram, you have to articulate the same thing in the form of code, right? So yeah, this one, these things you have to know before solving the LLD, right? LLD problems, LLD based problems. These are prerequisites, kind of prerequisites, right? So these are the things that you have to know at any cost, right? At least not everything, the fundamentals of it. Yeah. So you have to know these things before solving the LLD problems. Because within the LLD, so if you would have observed, actually, first, as usual, first what we do, uh, we discuss the question. After discussing the question, usually we collect the functional as well as the non-functional requirements in detail. Yep. After doing that, we move towards the solution part. First, we discuss the algorithm choice or the approach, what approach that we go with, and the design pattern choice, right? Design pattern choice, and also the principles. Usually, we discuss the solid principles as well, right? These this is the first thing that we do, right? So for this, you have to know certain algorithms. You have to know, you should be very good with the algorithms. Yep. So I'm not telling to mug up the algorithms, but at least you should know the algorithms, right? If you know the algorithms, then only you will be able to implement that, or you'll be able to articulate that one within the in the form of code actually in the future, right? So first we will be going with this. Then, if you would have observed, we went with this one, concurrency and the data modeling part. Concurrency, nothing but most of the times we'll be going with the thread safe operations, right? So you have to know the concurrency part, meaning you have to have the knowledge on this one, threading part. So mainly threading in the sense you have to have the knowledge on single threads as well as the multi-threads, and how we can implement the multi-threading in the Python. It's officially multi-threading is not supported in Python. We will be making use of the module so that we can simulate the same thing, multi-threading using threading, this one, what do we call a threading module or the multi-threading module, right? So in Python, as we have written the code entirely in Python for the 50 problems, I'm speaking of the Python programming language. Java is completely multi-threaded and JavaScript is completely single-threaded. That's different thing. Let's speak only on the Python. So we have to know the difference between the single thread as well as the multi-threading. So we should be able to implement both. Yep. So we have to have the knowledge on it for the concurrency part. And next, concurrency and the data model. For the data modeling part, you have to have the knowledge on the databases. Yep. So at least in our case, we didn't implement any this thing, what do we call uh, anything within the data modeling that includes the database. We just went in memory. Meaning we had made use of certain things. That comes within the programming language itself. In our case, we went with the whether it may be list, whether it may be dictionary, and other stuff within the Python. That itself we have made use of. In the Java, we have made use of the hash maps, hash set, other things. Yeah, same goes with the JavaScript as well, right? So we went completely. We considered the in memory rather than the external database. But you, in the real world scenario, you should have the knowledge on the database, right? Any database that you are working on, right? Usually the project that you are mainly working on, whatever the database you are using, that database knowledge you have to have, whether it may be MS SQL, whether it may be MySQL, whether it may be MongoDB, any SQL or the non-SQL database that you're working with, you have to have the knowledge on the database. Next, what we did after discussing algorithm choice and the design pattern choice along with the principles, then we went with the concurrency and the data model. Yep. After the concurrency and the data model, after discussing the concurrency part as well as the data modeling part, so we went with the this one, UML diagram. For the UML diagram, if you would have solved some HLD problems, or if you have the knowledge on HLD, then it will be very easier to design this one, UML diagram, right? So usually we will be going with a high level diagram. In our case, for the all this one, for 50 problems, we went with the textual representation. I went with the textual representation because it's easier to explain actually, right? It's easier to explain and it's easier to understand as well, right? You can just go with a high level diagram, or this one, what do we call, just to solve the problem, right? So you can just go with a high level diagram, or you can just go with a this one, textual representation as well, but you should be able to explain this. Fine. Then after the UML diagram, based on the UML diagram and whatever we had discussed earlier, we wrote the code. So whatever we write within the UML diagram, the exact same thing we'll be implementing or articulating in the form of code. Yeah, exact same thing. Only all we have to do while writing the code is we have to know the programming language, whatever the programming language that we are making use of. We have to this one, add the logics to the methods or the functions that we are this one implementing actually, that we are using actually. We have to implement, or we have to, yeah, we have to implement the logic within the methods or the functions, right? Usually while solving the problem, we will be making use of the class, right? Within the class, usually we'll be making use of different methods. Within those methods, we should be able to implement the logic, and uh, every other thing will be mentioned in the UML diagram itself, right? So whether it may be class, what are the classes that we'll be going with, and that is the reason we'll design the UML diagram basically. What are the classes that we'll be making use of? What are the methods we'll be making use of? What are the parameters that we'll be making use of, right? Uh, all we have to do is we have to add the logic to the different methods or different functions that we'll be making use of within the particular class, and what are the parameters, and writing the code structurally. That's it. These are the two things that we have to keep in mind while writing the code. Yep, we should know the programming language, we should write the code structurally, and we should be able to implement the logic within the method or the functions that we'll be using, right? For that, you have to have the knowledge on the programming language, oops concepts, yeah, programming language and the oops concepts actually, and the different design patterns, this thing, that thing, this one, whatever I said initially, the primary things, what are the things, prerequisites that we have to be good with before starting or before solving the LLD problems. Those things you have to know. Yep, so this is fine, I believe. After this one, writing the code successfully, after running the code, we should be able to discuss the limitations for the code that we have written. And one more thing, as I had stressed this one, most of the times, extensibility or yeah, extensibility is the part that we have to take care of. The code should be completely extensible, in the sense it we should be able to extend the code, right? Further, keeping that topic in the mind itself, we have to write the code always. Yeah, extensibility part mainly. Yep, so this is the thing that we have to keep in mind, mainly the extensibility part. Yep, so after writing the code, after running the code, if everything goes well, then we should be able to discuss the limitations for the code that we have written and how it is extendable in the future. And also we should be able to communicate this one, what are the alternate algorithms that we have went with, and why we chose the algorithm or the approach that we have implemented already, right? So why we went with that particular algorithm or the approach, and the alternative algorithms that we can consider as well, right? Or and the extensibility part as well. What are the things that we can implement in the future to make the code better, right? So that also we have to discuss. So everything, every algorithm or the approach that we have implemented, so that comes with a pros as well as the trade-off actually, or the cons actually. Yep. So this along with the alternative algorithms, we should be able to discuss the pros and cons, or discuss the this one, future algorithms, this one, alternative algorithms and the trade-offs as well, in simple terms. Yeah, so this is the way just to solve the LLD problems. And I have said you, or we have discussed what are the prerequisites that we need to have uh, before starting the or before solving the LLD problems. We need to know certain things that we have discussed. How we should solve the LLD problems, that also we have discussed. The only thing is, instead of the main high level diagram, we have considered the textual, this one we have went with the textual representation, or textual yeah, textual representation itself, right? So that's the only thing, uh, that's the change here, right? So it's good to, or it's better to go in this way, right? So this is fine. We have completely discussed, or we have completely solved the 50 problems, and this is more than enough, man. In the JavaScript, we have solved 15 problems. By making use of the Java, we have already solved 10 problems, and now 50 problems we have solved by making use of the Python programming language. Most of the important problems we have solved. Yeah, you can just watch the video. uh, and yeah, you can just watch the video. If you don't understand, you can just comment, and I'll be, if I see the message, I'll definitely reply to your comments. That is one of the thing. Yep. So let's finish it off with this particular problem, right? So we have completely solved 50 problems, and all the problems are available within the system design, this thing, LLD problems. Yeah. So LLD playlist actually. Yeah. System design LLD problem solved is the playlist name actually. All the 50 problems will be available. You can just watch the video. If you don't understand, or if you want me to improve in some way, you can just comment. I'll just reply if I see it. Right. This is fine, I believe. So yeah, and one more thing. For the next 1 month, or for the, yeah, for at least 1 month or two, so or 2 months, So I'll be busy. I have to prepare for certain things actually. I'll not be doing YouTube for at least next 1 month or maybe even 2 months. Yeah. So then we can move on with the further things actually. Let's see what we'll be doing further. I have not this one thought of anything. I have not I have really not thought of anything. So whether I'll be solving problems, whether I'll this one, whether we'll be discussing further with some frameworks. I have not thought of it anything, not thought of anything actually. But to be frank, let's see what we can do in the future actually. For the next 1 month or for next 2 months, I'll not be doing YouTube as I need to prepare on something actually. Yeah. So this is fine, I believe. Again, yep. Let's finish it off with this particular problem, designing the tic-tac-toe. We have successfully designed tic-tac-toe, right? So, yep. So I hope whatever we have discussed is completely clear along with the UML diagram and the this one coding part, right? So for now, this is it. Thanks for watching, guys.